I'm sat on HIFIm, High Frequency Impulse for Microgravity. It is the next generation of astronaut and para-astronaut exercise countermeasures, basically exercise equipment for astronauts in space on long duration missions. Why this is so good is because we can jump using this equipment. Jumping is fundamental for building bone and muscle. Now, astronauts lose bone and muscle mass ever so quickly when they're in space. This piece of equipment is proven through bed rest study that the European Space Agency's carried out that jumping for 4 to 6 minutes a day mitigates the deconditioning effects of being in microgravity. This piece of equipment does not require a vibration isolation system. So put that in context. The treadmill on board the space station, you see astronauts running on it. Underneath that treadmill is 900 kilograms of vibration isolation system. So the size of a small car, or the weight of it. This piece of equipment does not require a vibration isolation system. It's unique. It isolates its own functional forces and prevents them from being transmitted to the spacecraft. So it's totally unique on many, many ways. It doesn't need power to operate. We can even generate our own power through this system and produce it and give it back to the space station. Exercises on here, we can actually do everything that's available on the space station, as in, although they have a cycle machine, we can do cardiovascular work here, we can work the muscles, we can work the bones, but also some of the exercises are just not possible on the current exercise countermeasures currently on board the International Space Station. So it's truly unique for space.
In this particular configuration, it's all about non-destructive testing. So on the end, we have an ultrasound probe, and the robot's just sweeping across this component to check for any internal structural defects. Maybe it's a crack, maybe it's a hole, maybe it's a structural fault that we need to identify to assure the best quality for components ahead of flight. This is using ultrasound technology, so very similar to what you might use for a scan if you were pregnant to look at the baby. And on the screen there you can see there's effectively sound wave peaks being recorded, which are able to, the sound waves penetrate through the material and they're able to determine the internal structures of components. So we can tell the material depth, we can understand where there might be structural defects or problems inside the internal structure. It's a real challenge to get the people is the fundamental stumbling block, because there's not enough people to build these structures that are going into space. So one of the ways we can get around that is using robotic systems which are happy to work 24 hours a day, 7 days a week to carry out these tasks.
What do you see moving around? What do you see as the greatest opportunities?
The overall future of the space industry is fantastic, at a global level, and a lot of this is being spearheaded by people like Musk in the US. But even in the UK, where funding levels have been a lot lower from government historically, we're doing really well as a sector. What's great in the UK is the innovation. So we have companies here looking at doing things like returning samples from space, doing manufacturing in space, companies doing deorbiting of other satellites, going up, maintaining satellites, fixing them, moving them to different places in space. And we've got a lot of that technology and that capability in this room at the moment, which is fantastic. What the UK is brilliant at is doing the really early stuff, and what we need to get better at is then taking that and growing big commercial businesses out of that.
Accelerated the new space economy because things that were just simply not economically viable, small satellite manufacturing capability, we're broadly